Number 40, we've got two identical batteries of EMF 12 volts and an internal resistance of 0.2 ohms. They're connected to an external resistance R, either in parallel or series. If the external resistance is equal to 2 times the internal resistance, what's the current in the external resistance in the parallel and series arrangement? And then for which arrangement is I greater? So I've put the resistances and the voltages on these circuits. And let's take a look at the parallel one first. For the parallel one, I'm going to do a little bit of Kirchhoff. I'm going to assume the current going for each one of these is I. And because the circuits are identical, I'm going to do a little bit of cheating on this one and assume that the current in both of these, instead of calling it I1 and I2, are going to be the same because there's beautiful symmetry in this one. And that means if the current for each one of these is I, and then they're combining together down here, the current through this bottom resistor is going to be 2I. And now using the loop rule, we can quickly solve this one. We know that, and I'm just going to look at this bottom loop, by the way, just for clarity. I'm going to work around my loop in this direction. We know that the sum of the voltage drops have to equal the source of EMF in that circuit. And I've got it drawn this way. So the voltage drop through this resistor, 0.2 times I, plus the voltage drop through the external resistor, 0.4 times 2I, has to equal the source of EMF in this bottom loop, 12 volts. Solving that, we'll discover that I is 12 amps. Now remember, the current through this external resistance is actually 2I. And so what's the current through the external resistor? The answer is 24 amps. All right, doing the other one is much easier, the series one. In this case, we only have a single loop. Again, I'm going to call this current here I, the current over here I, and the current for the external resistor is also going to be I, because it's just a single loop. Solving this one, again with the loop rule, voltage drop through first resistor over here times the current, so 0.2I plus 0.2I plus 0.4I has to equal the source of EMF, and both batteries are trying to pump it in the same direction. So 12 plus 12. Solving this one, we get 0.8I equals 24, or I is 30 amps. And that's going to be the current through the external resistance. So which one has a greater current? The answer is the series one. Now we're going to change things. For the second part, we're now making the external resistance half of the internal resistance. So now they're both 0.1 ohms. Repeating what we did earlier, first of all, for the parallel circuit, again, I'm just doing this bottom loop. 0.2 times I times plus 0.1 times 2I equals the source of EMF in this bottom loop, which is 12 volts. Solving it, we get, you can very quickly see, I is 30 amps. That's for the internal, one of the internal resistances. And so the current through the external resistance is 60 amps. For the series one, very, very similar to what we did before, except now this number's changed. It's now 0.1 instead of 0.4, equals the source of EMF in that loop, which is 12 plus 12. Solving it, you'll see that the current here is 48 amps. This time, which one's greater? Parallel. Now, just a really quick side note on this one. Eveready and Duracell used to say that their batteries were better at powering certain things. How is that possible? How could one be better at one thing and the other one worse, and then the other company claiming, no, ours is better at this, and the other company's worse? Well, take a quick look at this. In this case, the parallel one was the better one. Why? It turns out, well, if you think about these two resistances as sort of being in parallel, and so this is about 0.1 ohm. That matches the external resistance we're dealing with. It turns out when the battery chemistry's internal resistance is similar to the load or the external resistance you're applying, you get more power transfer. Beforehand, these two resistances are in series. In series, these two were about 0.4 ohms, which is what it was to begin with when we originally had the 0.4 ohms. And in that case, this one was the better one to run that load. So it all depends on chemistry and the type of load that you're running. I hope that helps. Good luck.